This lesson is on calculating average atomic mass. Let us review what is atomic number. Atomic number is the number of protons in the nucleus of an atom. All atoms of the same element have the same number of protons, as you know. That is the identity of that element. And also you know number of protons equal number of electrons in a neutral atom. You can find the atomic number from the periodic table. Atomic number is the number on the top of each square in the periodic table. This will be the smaller number among those two numbers you can see in the periodic table. All atoms of the same element again will have the same number of protons, that is the identity of that element. And now what's the difference between mass number and atomic mass? We know how to find the mass number. You already learned by adding the number of protons and neutrons, which is a whole number. For example, for aluminum, it's going to be 13 protons plus 14 neutron, which equal 27. However, we cannot see that whole number in the periodic table. We see for aluminum, it is 26.981. That is nothing but the average atomic mass. This is not the mass number. In the previous lesson on moles, we explained that 1 mole of a substance is the molar mass. How did we conclude that? When we rearrange the formula to find the mass of 1 mole, we can see that the mass of 1 mole is nothing but the molar mass. Say for example here for aluminum, to find the mass in 1 mole, what we will do, we will take the molar mass from the periodic table, that is 26.981. We will multiply with 1, which equal 26.981 grams. So mass is nothing but molar mass, which is same as atomic mass. Only difference is we express that mass in grams. So now if we rearrange this formula to find the molar mass equal mass divided by mole. So when you put the units here, mass is in grams, mole is the unit. So molar mass we express in grams per mole. Whereas the atomic mass you can find from the periodic table, that is expressed in atomic mass unit. We call it as AMU. That's the only difference between the molar mass and the average atomic mass. So where is or what is the reason the average atomic mass is a decimal number? The mass number is a whole number. Average atomic mass we see is a decimal number. What's the reason for that? This is because of the existence of atoms of different masses for the same element, which are called isotopes. So isotopes are atoms of the same element with the same atomic number but different mass number. For example, boron has two isotopes. We represent that one as boron 10 and boron 11. So mass number here, mass number here. So abbreviated as B10, B11. We use the symbol and the mass number. Put a hyphen and put the mass number. That's the way we represent the isotope. Boron 10 has 5 protons and 5 neutrons. How is it different from boron 11? Boron 11 has 5 proton and 6 neutron. Similarly, we can see for sodium there are two isotopes, Na23 and Na24, which means one of the isotope is with 11 proton and 12 neutron, and another isotope will have 11 proton, see the same number of proton, but the second isotope of sodium will have 13 neutron instead of 12 neutron in the previous one. So sodium 23 and sodium 24, which differ in the number of neutron. So one isotope will have 12 neutron and the second isotope 13 neutron. Both will have the same number of proton. In the case of sodium, it will be 11. So all isotopes show identical chemical properties. A simple example to show the application of isotopes. Bond scans with radioactive technetium-99. Another example is a tritium content of groundwater is used to discover the source of the water, for example, in municipal water, or the source of the steam from a volcano. This is a question to check your understanding. Which of the following represent isotopes of the same element? Identify the element. How can you answer this question? Isotopes of the same element. So we learned that for the same element, the atomic number will be same. And also the atomic number is the smallest number among these two numbers. So let's check. This is 92, this is 93, this is 92 and 92. For the same element, the atomic number should be the same. So 1, 2, 3. And look at the mass number now. 238, 235 and 234. So the mass number is different, but the atomic number is same. So these three are the isotopes. How can you identify this element? Look in the periodic table for the atomic number 92. That is going to be the element. And now let's see how to calculate the average atomic mass. For example, boron 10 and boron 11. Okay, so boron is 20% of boron 10 and 80% of boron 11. That is, boron 11 is 80% abundant on Earth. For boron, how will you write the atomic mass? So how can we find the average atomic mass? So we have to use the formula. You have to memorize this one. Average atomic mass equal mass of each one of the isotope times its abundance, which is expressed in percentage here, plus mass of the other isotope times the percentage of abundance on Earth divided by 100. So just substitute. So I change this percentage as decimal. So 20 divided by 100 will be 0.2 times the mass is 10, and this one 0.8 times 11, that will give you 10.8 with a 3 sig fig AMU, because it is average atomic mass. Now try this question and compare your answer with your team members. If this part is clear, move on to the next lesson on average atomic mass calculation from mass spectroscopy data.